this flowchart tells us how registers help in receiving input or displaying output. So we have this flowchart corresponds to the input process and this one to the output process. We'll start with input first, and output is pretty similar. So you have a special purpose register called FGI, flag input, and INPR, input register. These two are special purpose registers present inside the CPU, which help you to collect input. So FGI or flag input is, as the name suggests, it's a flag variable. So if it is set to 1, it means a collection of input is going to happen. If it is set to 0, it means right now the system is not accepting input. It's either processing or displaying output, but input is not being accepted right now. So initially the flag is set to 0. We want to start the input process. We check if it is 0. If it is a 0, it means my system is not yet ready to accept input because something else is happening. So you just loop back and you wait until the system reaches a state where it is ready to receive inputs. And then once the FGI has been set to 1, and how it will change from 0 to 1 I will tell you in a minute. So once FGI has been set to 1, it means the system is now ready to receive input. So you will receive input from your keyboard, mouse, joystick, whatever, convert it to binary format, and it will be stored in your INPR, input register. From there it goes to your accumulator. This transfer from input register to accumulator happens only when FGI has become 1. So the accumulator will keep collecting as long as you have something more to offer, and then finally it will set the flag to 0 once everything has been collected, and it will end the input process. So now if the FGI was initially 0, how does it change to 1? It is because of something called an interrupt. An interrupt, as the name suggests, is an interruption which occurs from an external process. You will learn more about interrupts in one of the subsequent units of this course, as well as in your operating systems course. So I don't want to go too much into the technicalities of an interrupt right now. For now, assume that some external force is changing, external entity is changing FGI from 0 to 1. So I'll give you a quick recap of the input process again. We have two special purpose registers, FGI, flag input, which takes a 0 or a 1. If it's a 0, it means the system is waiting, and if it's a 1, it means the system is ready to take inputs. And we also have another register, INPR, which actually takes the input and keeps it. So initially my FGI is set to 0 or false. So when I start the input process, I am actually waiting, and then some external entity such as an interrupt comes and sets FGI to 1, indicating that my system is now ready to take an input. So from my input device, the input goes to an interface where it is converted to binary, and then it comes to the input register. From there it goes to the accumulator. The accumulator keeps accumulating inputs bit by bit, byte by byte, character by character, as long as you have something to put in. Once you've finished, once you have no more to offer, the FGI is set to 0 and the process ends. Again, the next time you want to give an input, an interrupt will set FGI equals 1, and the same thing continues. So that is how registers help in receiving input. Something very similar is the process for output. You have FGO, flag output, and you have OUTR, which is the output register. So again, if the FGO is set to 1, it means we are going to be displaying output. If FGO is set to 0, it means the system is not doing output related activities right now. It's either taking input or processing, but not doing output. So initially we start with FGO equals 1. Whatever is in the data register, we take it to the accumulator, and while the FGO does not become 0, we keep looping, we take everything into the accumulator, then finally everything goes from the accumulator into the output register. From the output register, it goes to the interface. The interface will again convert your binary data into visual or auditory information, and then it is passed to your monitor, printer, speaker, whatever. Finally, once the output process is over, again your FGO is set to 0 and you end. So it is, as you can see, it's very similar to the input process. It's just the names of the registers which change.